ladies and gentlemen.
So let's talk systems of nonlinear equations. So by this, I mean that we have a system, we have at least two equations that we want to be simultaneously true at the same time, where at least one of them is not linear. Remember, if we have a system of linear equations, we have really three possibilities. We have they intersect, they're parallel, or they're the exact same line, which is kind of also parallel. With systems of nonlinear equations, we have some uniqueness because of the beautiful curves that equations that are not linear produce. For example, if we have a quadratic, we have three possibilities, where, first of all, they're not going to be the same. We have two solutions where the line intersects a curve twice, or quadratic, or parabola twice. We have one solution if the line intersects the quadratic once, we would say it's tangent to it. And if we have no intersection at all, which can happen quite often, actually. So I don't want to scare you, but that's not all that could happen. This is all that you'll probably be asked on a standardized assessment, but there are other nonlinear equations. There's an infinite number, really. We have exponential curves where we could have two solutions. We could have a sinusoidal curve where we would have possibly infinitely many solutions. So on and so forth. It depends on the type of curves you're dealing with. But most common, you're going to be asked about a quadratic equation and a linear equation trying to be true at the same time. So, or two quadratics. So, how do we go about solving this? Well, you can use tools you already have in your arsenal to do this. We can use substitution, or we can use elimination, and I'll show you why we could use either one. So, first and foremost, I see that we have y equals a quadratic, y equals a linear, so that means that both of those statements to be true, the quadratic has to equal the linear. They are both equal to y, so we could substitute the quadratic in for the y for the linear, giving us x squared minus 2x minus 8 is equal to 2x minus 3. You can 100% do it that way, but then you have a quadratic equation. How do you solve that? You move everything to one side. So we can subtract 2x, add 3, subtract 2x, add 3, and we end up with x squared minus 4x minus 5. And you can do that. That is 100% fine. Oh, equals 0. We also have elimination. I can subtract this equation from the top. I can subtract linear from the quadratic. Y minus y is 0. X squared minus no x squared term would just be x squared. Negative 2x minus 2x would be a minus 4x. And a negative 8 minus a negative 3, minus a negative means plus. Negative 8 plus 3 is negative 5. We end up with the exact same spot. So don't be scared if you're like, I have to solve it this way, or I only know how to do it this way. Your method of solving a system of equations still holds up. You can substitute, you can eliminate, and you will end up with the same answer. So let's use this one over here. I have a little bit more room. This is factorable. We could use a quadratic formula, but it is factorable. Negative 5, factors of negative 5 that add to negative 4 would be negative 5 and a positive 1. So that means that our solutions would be x equals 5 and negative 1. And you would think, we're done. But we're not. Remember, for systems of equations, that we need the x and y coordinates of the point of intersection. The solution is a point of intersection. We just showed that we have two. So we have something like this, and the y values could be different. So we're going to take the simplest equation that we have. In this case, it would be the linear one. And we're going to substitute in the 5, substitute the negative 1, and see what the corresponding y values would be. So the y equals 2 times 5 minus 3, we get 10 minus 3, that is 7, so we get y equals 7. And for the negative 1, we have y equals 2 times negative 1 minus 3. 2 times negative 1 is negative 2, minus 3 would be a negative 5. So our solutions are 5, 7, and we have negative 1, negative 5. And there you go. There we have it. Not too difficult, really. You're using the same tools you kind of have in your tool belt already. We can use substitution, and sometimes there's methods and times where substitution is so much better. And then we have elimination, and sometimes that works out really, really well. So again, whichever one is best for the situation, or whichever one you feel the most comfortable with, stick with it. And that's it. If you have any questions, let me know. Otherwise, I'll see you in the next video.